So till now, you all including me have used the A9G board along with some other microcontroller board to provide the AT commands to our A9G board, right? But what if I say you no longer need any external microcontroller to give commands to the A9G board, as the A9G board in itself is self-programmed? And after hearing this, I know what your first reaction is going to be. Yes, it's definitely possible, and our team did a lot of research to find proper tools and proper firmware file to make this happen. And in this video, I'm going to share you the complete process about how you can use the A9G board standalone for all your GPS, GSM related activity. Well, do click the like button if you're already excited to learn that process. And with that excitement, let's just quickly start with this video. This video is sponsored by Altium, and they came up with an amazing product called as Altium 365. So Altium 365 is an electronics product design platform that unites PCB design, MCAD, data management and teamwork. So with Altium 365, you can do the PCB designing task, you can share your projects over web for review purposes. It do cover sharing your PCB file to mechanical teams so that they can create the mechanical product package based on your PCB. Then it also provides centralized cloud storage, so you don't need to rely on one single computer for your files. It also helps you with managing your components and get real-time supply chain data for your components. It also allows multiple people to work on single project, and in the end, it also helps you with sending your design to final manufacturing units. So Altium 365 takes care of all other tasks, so you put more time and effort in making something creative and useful. And the good part is you can try out its free version as well. I'll leave its free trial version link down in the description of this video, so do check that out. And now let us start with this video. First of all, you need to install Git for Windows, and for that just go to gitforwindows.org and click on the download button. After downloading, just install that file. Now, I have already installed it, so I'll cancel this download option. After installing, you just need to copy this link which I'll be providing you in the description. Just copy that and open up the terminal in your computer and paste that link here. After pasting, just press enter. After completing this step, you need to download one file called as csdtk42. After downloading it, just extract that file. I'm extracting it in my downloads folder only. After extracting, just open that folder and double click on this config env admin file. Click on run anyway and click on yes. After some time, just press any key to terminate this window. Now the next step is you need to go to GPRS CSDK folder. For that, you need to go to my PC, into C drive, into users. Now here select the user through which you are logged into your computer, and here is that folder. Just open up that folder, and here first press and hold the shift button and right click inside that folder. Here click on open PowerShell window here. Now in this window you need to type this command and press enter. After the process gets completed, just close this window. Now the next step is you need to open one application called as Cool Watcher, and for that go to your downloads folder, then into CSDTK, into Cool Tools, and here is the Cool Watcher application. But before opening this, we need to do two more steps. First, we need to download the firmware file, and for that you have to go to this page and just download these two firmware files. After doing that, we need to connect our A9G board for programming, and to program that, here I'm using my smallest TTL programmer which is set to 5V logic. Well, we are also selling the smallest programmer through our website, whose link you can find in the description of this video. And now we need to connect our programmer and the A9G board according to this connection diagram. After that, I'll connect the programmer with the computer, and after connecting, just press the power button on the A9G board to power it up. After doing these two steps, now open up the Cool Watcher application, click on run anyways, and here select 8955 and click on OK. Here click on allow access, and here we need to select the COM port on which the A9G board is connected, and after that just click on the connect button. This will establish a connection between our computer and the board. After that, click on the exit button. Here as you can see, it successfully made the connection. Now click on Flash, then choose Flash Programmer. Now here inside the Cool Tools folder, go inside the chip gen, then into Modern 2G, into Tool Pool, into Plugins, into FastPF, into Flash Programmers. And here select Flash SPI32 file. After that, click on this LOD icon and here just select the firmware file which you have downloaded. First select the full .lod file and click on open. After that, just click on the flash icon and here again select the COM port and click on the connect button. As you can see, it started flashing the firmware file. And after it is successfully flashed, just click on the LOD icon once again and this time select the flash.lod file and click on open. Once again, click on the flash icon and select the COM port and click on the connect button. With this, we successfully did all the steps for flashing the firmware. Now to test it out, we first need to change the connection between the programmer and the A9G board according to this connection diagram. And after that, I'll open the Thorny IDE, which is an IDE for Python. You can use any Python IDE. Now here, I'll click on Run, then select Interpreter. Here I'll choose Micropython Generic and select the port of my A9G board. After that, just click on OK. And here as you can see, we got the Micropython running successfully on our A9G board. Let us try it out our first Micropython code in it. And as you can see, we are able to interact with our A9G board using Micropython. So the firmware flashing on A9G board was quite successful. Now let's just write a sample Micropython script and install it in our A9G board. So here is the sample script to blink the LED on the A9G board, and if I explain you the script, then first of all we have included two packages. One is the machine which is responsible for all the GPIO pins interaction, and second is the time which is responsible for providing the delay in the script. After that we have provided a variable LED which is nothing but the pin number like GPIO27 which is working as the output pin. Now why GPIO27? Well, it's just because the built-in LED on the A9G board is connected to the 27 GPIO pin number and we want to blink the built-in LED, hence 27 is written here. After that we have given the value 1 to the variable value, and inside the infinite loop which is nothing but the while 1, what we are doing is we are giving the value to our LED variable, ultimately pin 27 as value which is nothing but 1. So initially we are turning on the LED, after that we are providing a delay of 1 second, and after that we are toggling the value variable, so now the value becomes 0. So ultimately we are turning off the LED. So we are basically turning on and off the LED at an interval of 1 second, and that's all about the script. Okay, now to upload or rather install that script inside the A9G board, first of all you need to make the connections between the A9G board and a programmer according to this connection diagram. After that I will plug in the USB cable, and here after plugging in you need to press and hold this power button for 1 or 2 seconds to make A9G board power up. After doing that, just click on the stop button, and here below in the shell section you should see this Micropython from A9G module. It should ready to accept any Micropython command. You can say if I type hello here, it should be working fine, and with this we can conclude that our A9G is successfully connected with the computer and A9G has a working Micropython firmware in it. Okay, so now we are ready to install the script. Let me show you how to do that. So here what I'll do is I'll click on file and click on save as icon. Now here as we want to install the script inside the Micropython device, so I'll select the Micropython device here. And here we need to give this file a name. I'll name it as main.py. Now you need to give this particular name only. It's just because in any Micropython device, as soon as it gets boot up, it will by default run a script called as main.py. So if we save it with this particular extension, this particular name, what it will do is as soon as we power up the A9G board, it will start running this LED blinking script automatically. Hence you have to give the name main.py. I'll click on the OK button, and yeah, as you can see the name changed to main.py. So we successfully saved the script into the A9G board, and now let's just power up the A9G board separately and let's see if this script starts running automatically or not. So here is the A9G board. I'll remove all the connections with the programmer, and what I'll do is I'll just insert a micro USB cable to power up this board. And now let's just wait. Okay, as you can see, here is the built-in LED and it started blinking at an interval of 1 second. That means we have successfully installed the script in the A9G board and it started running automatically at the time of boot up. So this is how you can write any Micropython script and install in the A9G board, and it will start running automatically standalone without any external microcontroller. Now for all those who want the AT command firmware back onto the A9G board, well, we can definitely do that, but it has a different process to do that. Let me show you a complete step-by-step process to get back that AT command firmware. Now to go back to the AT commands firmware, you first need to go to this page and download the firmware file and the burning tool file. In my case, I already downloaded both of them. So first I'll go inside this firmware tool folder and open this FP upgrade application. Now here, click on these three dots and select the firmware file for the AT commands which you have just downloaded. After that, we need to select the right COM port, but here unfortunately the COM port is not visible. So what I did is I just pressed and hold the power button on the A9G board and the COM port appeared on the application. Now as soon as the COM port appears, just click on the start button and then you can release that button. So it started flashing the firmware file on our board. After some time, it will get successfully flashed onto our A9G board, and now our A9G board is ready to accept the AT commands. Now to test that, first I'll open up Arduino IDE, and in the meantime, I'll change the connection between our A9G board and the programmer according to this connection diagram. After that, I'll press the power button once again to power up the board. Now I'll select the COM port in Arduino and open the serial monitor. And here if I type AT, then yes, I'm getting the OK response from the board, means now it is back to the AT command firmware. So that was all about flashing Micropython firmware on A9G board. Well, I'm looking forward to make a couple of more videos, or rather a getting started video of A9G board, but this time using Micropython firmware. And in that video, I'll show you a couple of examples like how to, send SMS using A9G board, how to connect with MQTT broker using A9G, how to get the GPS coordinates and so on, but this time using the Micropython scripts. So make sure you subscribe to the channel if you don't want to miss upcoming really interesting and useful videos on A9G board. And yeah, that being said, I'm just ending this video here, and now just wait for my next video and explore, learn, share with me, techiesms.